Hello there. We've just made the world's first retractable plasma-based lightsaber. Big thank you to our YouTube members and Patreon supporters for supporting the channel. They get tons of perks, including seeing our videos before anyone else, like the lightsaber test video, which is available on our channel right now for members. A real, retractable, plasma-based lightsaber. The pinnacle of sci-fi tech. And probably one of the most sought-after fictional technologies ever. As you know, we've been developing different lightsabers, or like they're called in Star Wars lore, proto-sabers, for the past 4 years now. From some initial power supply tests that got the fire department called on us, to version 1 using nitinol wire, to version 2 using a tungsten titanium blade hybrid, version 2.1 so we could have a real-life lightsaber duel, which, by the way, was extremely unsafe, to finally our Kylo Ren style lightsaber complete with a 3D printed titanium hilt. A proto-saber, of course, is a lightsaber with an external power pack. Since, you know, we don't exactly have D-sized batteries capable of putting out more power than a nuclear power plant, which, by the way, is what you'd need for a lightsaber to function like it does in the movies. Now, in my opinion, what we've made so far are some of the closest representations of lightsabers using real-life technologies. They look like a lightsaber, they sound like a lightsaber, and at temperatures of over 3,000 degrees, they actually cut stuff, like a lightsaber. But as you know, the internet is not easily pleased. Those are just red-hot sticks. That's just a red-hot piece of metal. That's not even a real lightsaber. Your lightsaber sucks, and you should feel bad too. Luckily, I have thick skin, since I've read over 500,000 comments on my YouTube channel. That's equivalent to like 200 full-length novels, by the way. So despite the trolls' best wishes, we have not given up. Which is good, since, you know, you could count on one hand the amount of people in this world actually working on lightsaber tech. Anyway, how the heck do you make a plasma-based lightsaber? Well, best theories say that plasma is held in a beam by a magnetic field, which scientifically checks out. You see, the issue is producing a strong enough electromagnetic field to contain a blade. Well, the lightsaber would quite literally have to be built inside of a box coated in electromagnets, which turns it into kind of a useless science project. Woo, I made a lightsaber. Luckily, we've come up with an alternate solution to control the flow of plasma, which allows us to make a retractable blade, and even change its color. We're going to be using laminar flow. You know, that cool thing where liquids flow smoothly? We actually teased this project months ago on our Instagram, which maybe we shared too soon, since it's resulted in almost all new comments being, "Where is the lightsaber?" I mean, come on guys, it might not be brain surgery, but building a lightsaber is basically rocket science. It's taken us quite a few months to get just right, and we also had to upgrade our equipment in the shop to even be able to manufacture it, like our new Tormach 1100 MX CNC machine, complete with a 4th axis. Bogdan's been pretty excited to try it out. And since Star Wars was a long time ago in a galaxy far, far away, it's only fitting that our first real plasma lightsaber is steampunk. I think it's Bogdan's turn to design that hilt.
Steampunk is a subset of science fiction, which incorporates antique design aesthetics from the 19th century with modern technologies. When I was scrolling through to get some design inspirations for the lightsaber, I came across this picture and it instantly caught my attention. I think steampunk would be great for this design because we're going to be using a lot of gauges, valves, copper tubing, and regulators, which are going to look perfect in this installation. Here's the final design of our lightsaber hilt. It incorporates lots of materials including brass, copper, stainless, glass, and even leather to give it that true steampunk look. I've even decided to add the kyber crystal heating chamber using some EL wire and a neon bulb to make it look really cool in the dark. The copper pipes that carry our flammable gases are nice and visible, and the adjustment knobs are easily accessible. Thanks to our new Tormach machines, we are now able to manufacture much more intricate designs, such as this one. Let's make it real.
This video is sponsored by AFK Arena. AFK Arena is a light RPG, the best RPG for the busy you. As you know, we're always crazy busy here at Hacksmith Industries, which is why we like AFK Arena. It's a rewarding, non-grindy style RPG, so it doesn't require a huge time investment. It's easy to get into and can be played casually when you have time. I've actually caught the team playing AFK between doing work, but hey, that's okay.
How's it going? Oh, you're not even machining, you're playing a game. What are you doing, man?
Just playing AFK Arena. Come on. It's running on its own.
Fight demons, get epic gear, collect heroes, and level them up. Unlike most RPGs, AFK also has a cool fresco art style, which makes it so much different from all the others. It's refreshing. Team up with 7 unique factions and different hero unions to enhance your strategy and come out on top. With so many different characters to choose from, you feel like a collector. Plus, if you use my link below, you can get a special hero, either Zafrael or Lucretia. They're Celestial and Hypogean elite heroes. Seize the opportunity and download AFK Arena today. Plus, it helps support our channel. Oh my God, that looks incredible.
Hey, whoa, put some gloves on.
Oh, sorry. Can't get any smudges on the lightsaber. That is incredible. I think you've outdone yourself on this one, Bajan. Look at the detail in that. If that's not steampunk, I don't know what is. But the real question is, how are we gonna power this? Even with all of our new equipment and capabilities here at Hacksmith Industries, we're still kind of bound by the laws of thermodynamics. Which means we're still gonna have to make this into a proto-saber with a power pack separate from the hilt. Now, we've made incredibly energy-dense power packs before, but in order to get enough power for a plasma-based lightsaber, we're gonna have to use something with more energy-dense fuel. In this case, LPG, compressed liquid propane gas, which can give us 50 times more energy per kilogram than a LiPo. Now that's a pretty incredible difference. And the cool thing, you probably have this right at home. We're talking about normal propane that you use in your barbecue. So how do we turn propane into a superheated beam of plasma? The answer lies with one of the most satisfying demonstrations of physics phenomena of fluids, laminar flow. Basically, we need a large array of laminar flow nozzles to create highly concentrated flow of gas to create a plasma beam. Lucky for us, we aren't the only ones who need this, and highly specialized gas nozzles like this can be found at a rather high price. This nozzle right here costs over $4,000, and it's used in the glassblowing industry. To achieve maximum temperature, we need complete combustion, which means in addition to this propane, we're actually going to be using oxygen as well. That doesn't sound dangerous, right? Anyways, let's see how it works. First, turn on the propane. Then we turn on the oxygen, some safety glasses, and the sparker. So look at that. Is that not a lightsaber? This beam is really cool. It's actually burning at around 4,000 Fahrenheit, which means it's capable of cutting through a lot of stuff. Should we cut through some stuff?
Whoa.
So this is actually our old lightsaber blade made of titanium. And look at that. It's already white hot. That is so bright. Jesus. The really cool thing about doing a flame like this is we can actually color it using salts. Let's start with some boric acid. What color do you think it's going to turn the blade? Got your guesses? Ooh, look at that. Next up, we have calcium chloride. Woo! Look at that red-orange. That almost hurts to look at. We have some strontium chloride. Woo! That is like a road flare. This actually hurts to look at. Look at that. Finally, we have some sodium chloride, also known as salt. Woo! And look at that. We've got Ray's lightsaber right here. Is that not cool? So we're able to produce a blue lightsaber, a green lightsaber, a red lightsaber, an amber lightsaber, and even a yellow lightsaber. How awesome is that? I should probably turn this off though. That took a lot of fine tuning to get the blade to the right length, and turning it off wasn't the most elegant. Luckily, Bogdan's going to be actually making a circuit with two fancy valves, which means we'll actually be able to get a computer to control the flow of gas to allow for this to ignite and retract with the press of a button. So I'm going to let Bogdan handle that.
After 12 weeks of anticipation, we finally got our hands on proportional control valves. These will allow us to control exactly how much gas goes into the lightsaber, and therefore make it extend and retract. Now, we just need to figure out how to control it. And to do that, I'll be making a custom printed circuit board. I'm going to be using Altium Designer, as it's the industry standard for PCB design software, and it's super powerful. This is the printed circuit board that Charles designed to use for the Crisis Arm. But since both projects are using pneumatic valves and auxiliary outputs, we'll be able to use it for our lightsaber with some minor modifications. This board looks great. If you want to view this PCB yourself, you can use Altium Viewer. One of the only machines we don't have in the shop is a PCB mill, but why would we get one of those when websites like JLC PCB will allow us to order high quality boards in a matter of days for just $2 for 5 boards? We need like 15,000 boards to make up the cost of one of those machines. Let's get these ordered. While we wait for that, I'm gonna guess. Well, that was quick. Let's start soldering. Okay.
To better understand how the lightsaber electronics work, check out our page on maker.io.
We've got to build a steampunk power pack with these pieces. I'll let Chris handle that.
Well, this all needs to be polished before I can start building. I'm going to let Dave handle that.
No.
Fine, I'll do it myself.
We did it, the world's first retractable plasma-based lightsaber. Now obviously we're gonna have an amazing test video for this. We've got tons of stuff set up behind us to really put this through its paces, including cutting through a steel door. Anyways, that video is actually available right now for our Patreon supporters and YouTube members, which is a great time to support the channel and get to see this video early. For everyone else, it'll be out next week. Thanks for watching, and make sure you subscribe.